So when we have problems like this, we've got to get a similar base. With 4 and 32, they can be both written with a base of 2. And now we have 4x plus 8, 5x minus 25. Okay, what you have to recognize here is this is all manipulation. I'm not changing the value of anything. 2 squared equals 4. 2 to the 5th equals 32. When you have a power to a power, you're multiplying, so you're distributing through the exponent. Once I have same bases, the bases are useless to solving the problem. I don't need them anymore. I'm simply setting the exponents equal. 4x plus 8 equals 5x minus 25. I'm going to subtract 4x on both sides and get x. I'm going to add 25 on both sides and get 33. That's my answer. You're going to get some weird numbers here. That's okay. In fact, that's probably one of the more normal ones. Here, 5 cubed represents 125. Here, 5 squared represents 2x plus 7. So 5 to the 9x minus 15, 5 to the 4x plus 14. Now I'm going to take both those exponents and set them equal. Once I have similar bases, I don't need them anymore for solving the problem. I've just got to set the exponents equal. I subtract 4x on both sides, I get 5x. I add 15 on both sides, I get 29. My answer is 29 over 5. Be shocked if you don't get a lot of fractional answers here. I'm not saying every answer has to be a fraction. Clearly the previous one wasn't. But having a fraction answer here should not be something where you're like, oh, I must have done it right. Or I'm sorry, I must have done it wrong. There's a good chance you're going to get fractional answers in these. 1 over 81, I'm going to write that as 3 to the negative 4th. 3 cubed, 3x minus 2. 3 to the negative 4x minus 16, 3 to the 9x minus 6. Are there any questions with that? Same base to the exponent. And now I'm going to set those exponents equal. I'm going to add 4x to both sides, I get 13x. I'm going to add 6 to both sides, I'm going to get negative 10. Absolutely negative 10 over 13 can be your answer. I know it's... We're just following the log rules, ladies and gentlemen. 4 to the x equals 64. I need to know that 4 cubed is 64. X to the negative 3 equals 1 over 27. What can I raise to negative 3 to get 1 over 27? 3. That's it. 2/3 to the 4th power equals x. 2 to the 4th is 16. 3 to the 4th is 81. It's literally that straightforward. Here, when you have a radical like this, 8 to the x equals the cube root of 8. I can write the cube root of 8 as 8 to the 1/3. So therefore, that's what I'm raising it to, the 1/3. We have to be able to translate radicals into fractional exponents. And the bottom two are pretty straight. So this problem here that we had to correct, x to the 1/2 equals 7. The square root of what number would give you 7? It's 49. And then here, we should know at this point, anything raised to the 0 power is 1. Those are those 6. So here, 3 to the 4th equals the x minus 3. 3 to the 4th equals x minus 3. 3 to the 4th is 81. I add 3, my answer is 84. And that's your answer. Second one. When you have the same log on each side, you can just set them equal. Now, unfortunately, in this problem, we get 2x here and a negative 14, and x equals negative 7. This is a no solution. And the reason it's a no solution is when you plug negative 7 back in, you get negative numbers there. You can't have a negative number there. Okay? So it's a no solution. So here we're setting these two equal. We subtract 20 on both sides. And now we're factoring. X plus 10, x minus 2 So my two answers are 2 and negative 10. Since negative 10 creates a positive 20 here and 2b creates a positive 20, both answers are good. So log base 3, we're going to put the exponent up there. Log base 3, we get 3y cubed minus log base 3z to the 4th. I'm going to change, and I'll write it out. 3 cubed is 27y cubed. And now, we can get this all to one log. X squared times 27y cubed is 27x squared y cubed, minus we divide z to the 4th. And there's our answer. Our second one, I would recommend dealing with the parentheses first. 4 log base 2 xy minus log base 2 2z cubed. So this becomes log base 2. My advice, the 4 goes to the x and y. This is where I think the use of parentheses is very helpful. Minus log base 2, 8z cubed. I'm cubing that number. And then from there, log base 2, xy to the 4th over 8z cubed. So for the first one, where each number has individual exponents, I'm going to start out by doing this. Log base 4x squared plus log base 4y in parentheses minus log base 4z cubed. Now, when we expand, those exponents have to be thrown to the front. 2 log base 4x plus log base 4y minus 3 log base 4z. That's the answer. Now the second one, when you have an exponent outside parentheses like this is what I would do. I start by putting the 3 in the front. So log base 5, 4x over 5y. And now I'm going to break that log down. Log base 5, 4 plus log base 5x. That simulates the multiplication in the numerator. Minus, because we're dividing, log base 5, 5 plus log base 5y. Okay? That right there is the answer. So here's my answer up here. Here's my answer down here.